guys, today we're going to be talking about how to solve linear inequalities in two variables. We are going to be solving inequalities by using the test point method and also by shading above and below. But we're going to take a little different spin on this for this video. We are going to show the answers first, and then we'll talk about how to do it by hand. So the first problem we are asked to do is we are asked to graph the solution set of this inequality. Inequalities scare me, so what I'm gonna do, I'm gonna go ahead and pretend it was an equation. So I'm gonna go ahead, use my fancy calculator, Desmos, and I'm gonna replace the inequality symbol with the equal sign. So we have 3x minus 3y equals 0, and then I know that that the graph of an equation is a line. Why? Because these are gonna be all the ordered pair solutions. Cool. But now it's time to face my fear. So let's go ahead, graph the actual inequality, which is 3x minus 3y is less than 0. Cool. So we have a little coloring action in there, or some shading. Let me turn off the equation. Okay. So the question is, why do we have this dashed line? So let me go ahead and hide it. When we had an equation, the graph of a linear equation is just a straight line. It could be slanted, vertical, or horizontal. But the question is, when we have an inequality, sometimes the points on the line may or may not be a solution. This is kind of like along the lines of open and closed circle. So if the inequality symbol has the equal to part, I call it equal to part because it's not really an equal sign. Equal sign has two horizontal bars. But when we combine the inequality symbol with the equal sign, we just have one horizontal bar. Okay. So if the inequality symbol has the equal to part, then we can draw the graph of the line. But if the inequality symbol doesn't have the equal to part, like right here, then the points on the boundary line are not part of the solution. So this is why we do a fake line or a dashed line, how it's called in books. Then we're going to do some cool math to see where are the rest of the solutions. Are they above the line, above the boundary line, or below the boundary line? And we'll explore both techniques. The question is, why is it that we shade or color? We shade or color because this inequality has many solutions aside from the ones that are on the boundary line. Well, for this problem, none of the points on the boundary line. So when we have equations, the solutions are the points that are on this line. Okay, inequalities for this problem, maybe I should have started with a slightly different one. But first we want to point out, is the boundary line part of the solution set? Meaning, are the points on the boundary line part of the solution set? Again, the inequality symbol doesn't have the equal to part, so none of the points are in. Once we establish that, we ask ourselves on which side or which half plane are the actual solutions. In this case, they're above. So we have a point, what is that? 0, 1, and then -1, 1, and so forth. So pretty much the actual solutions are going to be on this top half, but it's not feasible to graph it's not feasible to, okay, wrong thing. Okay, yeah, I was trying to do something, but it's not working for me. So it's not feasible to graph all these points one at a time. So this is why we do the shading. So when do we do the shading? We do the shading if we have the inequality symbol. Okay, this is in my way now. Okay, fantastic. So that will be the answer, and in a bit we'll do it by hand. So this is not working for me. This is what I get for doing things that are out of my comfort zone. Okay, up next in the agenda, we are asked to graph 2x plus 1 is greater than or equal to 6. So again, I'm going to pretend that the inequality symbol was the equal side. So we have 2x plus 1 is equal to 6. So we do some math, and then in this case, the graph will be a line. Because we only have the x variable, then we should have a vertical line. Okay, why are we not graphing? Oh, because you guys can't see it. Oh, sorry. I should start this video from the beginning, but we have no time for that. Okay, cool. Okay, so if we replace the inequality symbol with the equal sign, then we're gonna have an equation. So again, the equation only has the x variable, so x only, so we have a vertical line. But now it's time to face our fears, and let's go ahead graph the actual inequality. Okay, so we have 2x plus 1 is greater than or equal to 6. So now the question is, aside from aesthetic aesthetic results. One of the main difference between this inequality and the other one is that the boundary line is part of the solution. The first problem, the inequality symbol didn't have the equal to part, so we couldn't do the line. We had to do a fake line or a dash line. In this case, for this problem, the inequality symbol does have the equal to part, so the points on the boundary line are part of the solution, so we can graph it. So we graph it like our normal lines. Then we're gonna do some cool math to see on which side should we shade. We'll do the math, and it looks like we shade to the right. Fantastic. Final problem. We are asked to graph 2y minus 3 is less than 4. You know how I'm gonna take this problem. I'm gonna pretend this was an actual equation. So we're gonna replace the inequality symbol with an equal sign. So let's go ahead, hit enter. I learned my lesson. I gotta turn it on. Fantastic. So in this case, we have an equation that only has a y only. We should have a horizontal line, and then we do the math to see where to draw the horizontal line. But let's go ahead, face our fears. So let's go ahead, graph the actual problem. So we have 2y minus 3 is less than 4. Let me go ahead, turn off the equation. So as you can see, because we have an inequality symbol that doesn't have the equal to part, that means that none of the points on the boundary line are part of the solution. The question is, why do we do this dash line? We do the dash line just so we know where to stop coloring. Okay, cool. So we'll do some math, and then the math will tell us that we're gonna shade below the boundary line. Cool. So again, this video we did it in reverse order. First, we gave the solutions, and then we're actually gonna do the solutions by hand. Give me one sec, guys. Okay guys, so now it's time to redo those same problems that we worked out with Desmos, and it's time to redo them with our pen and paper. Well, pencil and paper, because you know, pencil gives us the liberty to make a mistake. Okay, so we're gonna go ahead talk about two different ways to graph the inequalities in two variables. The first time around is by selecting a test point. If you must call it something, is you can call it test point method. The second technique is by using the slope-intercept form method, but who has time to write all of that? So we're just gonna say we're gonna graph by shading above or below. So I labeled it the above or below method. Okay, so regardless of what technique you use to graph the inequalities in two variables, the first thing you need to ask yourself, is the boundary line part of the solution? So we can make that call now, or we can make it later once we're ready to graph the actual boundary line. It's a personal choice. But the question is, how can I tell if the points on the boundary line are part of the solution? Well, that is going to be dictated by the inequality symbol. If the inequality symbol has what I call the equal to part, you know, so if we have an is less than or equal to, or is greater than or equal to, then that means that the points on the boundary line are part of the solution. It's kind of like saying, like, if we were to graph m is greater than or equal to 2 on the real number line, then first thing we want to say is that number part of the solution? So it is. By we'll do a close what is it? We call it closed circle, but it's just a point. And then we graph the rest of the solutions. Okay, so similar for inequalities in two variables. So the first thing we want to ask ourselves, is the boundary line or line part of the solution? If the inequality symbol has the equal to part, then the points on the boundary line are part of the solution. So what do? We just graph them. So we graph them with like a regular line, like back in the day. But now that we're inequalities, the book will say solid line. Now, what if the inequality symbol doesn't have the equal to part, as in case, oh, problem A, yeah, I misread it. Okay, so if the inequality symbol doesn't have the equal to part, then that means that none of the points on the boundary line are part of the solution. So we will have to do a fake line, but no one speaks like that except for myself. So if the inequality symbol doesn't have the equal to part, then we're going to do a fake line or a dash line. So coming back to an earlier chapter, you know, getting out of the XY plane, we graph m is greater than 2. So in this case, the solutions are the values that are strictly greater than 2. So we'll say like open circle. But if you ride with me, then we say, you know, fake point. Okay, so yeah. So moral of the story, first things first, we have to do the graph of the boundary line, and then before we connect our 2 points, we are going to ask ourselves, are the points on the boundary line part of the solution? If they are, we graph the line, and if they're not, just kidding, we'll do a fake line. And then we're going to select the test point to determine on which side of the boundary line do we shade. Fantastic. Okay, so it says graph the solution set, and students, please, if we are doing straight lines, well, oh, that's pretty straight. I'm so proud of myself. But under normal circumstances, I don't make them that straight. I need you to use a ruler or some other straight edge. And the reason why I say straight edge is because we're not measuring anything, so it doesn't have to be an actual ruler. I have this nifty book marker, plastic book marker that I keep with me. But yeah, or any plastic card will do. Okay, so the question is that I get from students a lot is how can we tell if it's a shading problem? If we have an inequality, we're shading. Equation, equal sign, no shading, just do a line. So let's go ahead draw the graph of the boundary line. So we'll put we're going to graph it by using the slope and y-intercept. So let's go ahead, put this in slope-intercept form. So a gentle reminder, an equation is said to be in slope-intercept form if it looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so let's go ahead, solve for y. So we will subtract 3x from both sides, and that will leave us with negative 3y is less than negative 3x plus 0, but there's no need to do that, okay, to bring down the plus 0. Work your magic. Let's go ahead, isolate the y by getting rid of the times 3. To get rid of the times 3, let's go ahead, divide both sides by negative 3. And a quick reminder, I'm going to go ahead, bust out the sirens, because at any point, if we multiply or divide both sides by a negative number, we have to reverse the inequality symbol, but no one speaks like that. So in English, if you divide or multiply by a negative, you got to flip the inequality. So our statement should read y is now greater than, where am I, x. Cool, fantastic. So now the question that I'm going to ask myself is this: are the points on the boundary line part of the solution? In English, can I graph the boundary line? And the answer is no, because the inequality symbol doesn't have the equal to part. So I'm just going to put a love note to myself and say that we have a dashed line. Okay, so because this is in slope-intercept form, let me go ahead, identify what I need. So the coefficient on x is the slope. The coefficient is 1. If you want to insert a special effect, go for it. Okay, so we have that the slope is 1. The constant term is the y-intercept. There is no constant term, so let's go ahead, insert our special effect 0, and that will give us b equals 0. Okay, so let's go ahead, use this information to do the graph of the boundary line. So the y-intercept is at 0, so we locate 0 on the y-axis. We apply the slope, which is 1. If need be, go ahead, write it as the quotient of 1 over 1. Then with confidence, we're like, oh yeah, rise is 1, run is 1. So we go up 1, 1 to the right, up 1, 1 to the right. We have already established that none of the points on the boundary line are part of the solution. So hence we do a dashed line. Okay, so let me just use my my other pen. Yeah. Cool. All right, so that was the slope process. Fantastic. So when we do our dashed line or fake line, don't say fake line, no one will understand you, okay, unless you talk to me. So when we do a dashed line, we have established that none of the points on the boundary line are part of the solution. But now the question is, where are the actual solutions? Are they above the boundary line, or are they below the boundary line? So in order to make the call, we're gonna select the test point. What is a test point though? A test point is exactly what it sounds like. It's a point that we're going to test out to see if it's a solution. The good thing is that you can test out any point of your liking, with the exception of those that are on the boundary line. Now, you know that 0 is my favorite number, so I would love to test out the point 0, 0. But in this case, I can't, because 0, 0 is on this line. So I'll just go over here. I'll test out what is that, 1, 0. Okay, so let me go ahead, put the inequality. Where am I? We have y is greater than x, and then our test point, I'm gonna abbreviate it by TP. Cool. Yeah, it sounds weird, but whatever, I don't have a lot of space. So I want to know, oh, Oh no, that's my favorite number, huh? I said we can't use it because it's on the line. Oh, we're testing out 1, 0. Yeah, put it in the blooper reel. Fantastic. Yeah, that looks even worse. Okay, so we're gonna test out 1, 0. Okay, so I want to know, is 1, 0 part of the solution? Okay, let me go ahead and do that. So we have let me go ahead and put XY for my peace of mind. You know me, I like to put the numbers in the wrong place. So we have Y, in this case is 0. I want to know, is that really greater than X, which is 1? So I'm like, is 0 bigger than 1? Okay, 0 bigger than 1. 0 is not bigger than 1. Okay, this is a false statement. So you could, I like to put X like it checks out, or I like to put a check mark if it's a solution, or X if it doesn't check out. But if you want to keep it with the book notation, then you put false. Okay, now this is what's going on. 1, 0, our test point is not a solution. Because it's not a solution, I can't graph it. And because it's not a solution, then none of the points on the same side are going to be a solution. So since our test point didn't check out, then the actual solutions are the points that are on the other side of the boundary line. So I'm going to shade over here. Okay, looking at the notes, says pick a test point, check it out. Oh, I deleted it. Okay, if you get a false statement, then the test point is not a solution, and we shade the opposite side. So I'm just gonna put false. So shade the opposite side. So when I say opposite side, I want you to shade the side that's on the other side of the boundary line. Okay, so our test point is here. It's not a solution, so we shade the opposite side, which is over here. So you're gonna take your pencil. You would think I will have a pencil ready, right? But I wasn't planning on using a pencil. Okay, where are my pencils? Let's go ahead and put a pause on this thing. Okay, so I found it. Okay, so to recap, our test point is right here. It didn't check out, so it's not a solution, so we're gonna shade the opposite side, so the side that doesn't cover my test point, which is over here. So what I like to do is I like to shade the edges first, and then I'll do my best. So this is like a lead pencil, so it takes me a little bit longer. Yeah, that does not look good on camera. Okay, if I would have known, I would not have wasted my time to look for the pencil. Okay, so let me go ahead and use a highlighter. Okay, so for students, I do recommend that that you use a pencil, because it gives you a liberty to make a mistake. But if you have to scan in your work, you may have to use a highlighter or a pen. I think that looks good on camera. You can see it. Okay, cool. And if we compare it to the Desmos solution, that should be the same. Okay, cool. So that's 1 down, 2 more to go. Well, 2 more to go for using this technique, and then we're gonna do 2 more problems using my favorite technique. No bias right there. Okay, problem B. So we want to graph 2x plus 1 is greater than or equal to 6. If I didn't have this graph area, then I would be like, okay, that's an inequality in one variable. Let's go ahead graph it on the real number line. But in this case, because a graph paper is provided, then it's like, okay, I guess we graph the results on the XY plane. So unlike problem A, we don't have both X and Y variables, so the boundary line is not going to be slanted. It's either going to be a vertical or horizontal. Yeah, sorry, it's either going to be a vertical line or yeah, that looks worse. So scratch that. Okay, so this inequality doesn't have both X and Y variables, so the boundary line or the line is not going to be slanted. X only, it's either going to be a vertical line or a horizontal line. If we keep our cool X only, then we have a vertical line. But you don't have to memorize that. You can just do an XY table, okay, and let the math speak for itself. So if we, in this case, we're going to solve for the only variable that we see, which is x. So let's go ahead, subtract 1 from both sides, and that will give us 2x is greater than or equal to, where am I, 5. We keep our cool. After we divide both sides by 2, that will give us that x is greater than or equal to 5 halves. Okay, so in this case, we have a vertical line that intersects the x-axis at 5 halves. Where is 5 halves? I don't know. So let's go ahead and write it as a decimal or mixed number. Okay, we'll write it as 2.5. So we have a vertical line that intersects the x-axis at 2.5, but you don't have to memorize that. You can just do an xy table. Okay, if we do the xy table, pretending this was an actual equal sign, this reads x equals 2.5. So the value of x is locked in at 2.5, so we're gonna have to pick y values. Okay, so my favorite y value is my favorite number, 0. Well, I like 0 is not my favorite number, but in the math classroom it is. When y is 0, I'm supposed to substitute a 0 for y and solve for x, but there is no y, so guess what? X still equals 2.5. So that will be our first point, okay? 2.5 comma 0. So 2.5 to the right, and then we stay put because y is 0. Then let me see if I can zoom this in more. Okay, that's large as it's gonna go. Okay, cool. We need at least 2 points to do the graph of a line, so I'll pick my next favorite y value, which is 1. So same speech. When y is 1, we're supposed to substitute a 1 for y and solve for x, but there's no y, and x is still 2.5 because the value of x is locked in at 2.5. So let's go ahead and graph it. So we have 2.5, x is 2.5, we go 2.5 to the right, y is 1, so we go up 1 unit. Now the question is, before I connect the points, I have to ask myself, are the points on the boundary line part of the solution? Or in English, can I graph the line? We can graph the line because the inequality symbol has the equal to part. So I'm just gonna say solid line just to keep it consistent with the books. Okay, so let's go ahead, take our straight edge and connect the points. Okay, so let's go ahead, take our straight edge, connect the points. We said solid line, right? Yes. Okay, so let's go ahead and graph it. So now the question is, on which side of the boundary line are we gonna start shading, the left side or the right side? We haven't discussed the other technique, so I can't eyeball it. So we're gonna graph the solution set, well, the rest of the solutions, by selecting a test point. So again, a test point is any point of your liking as long as it's not on the boundary line. You know that 0 is my favorite number, so I'm gonna test out the origin, 0, 0. So let's go ahead, write down the inequality. X is greater than or equal to 2.5, and our test point is 0, 0. And then let me go ahead, label it with xy. So I want to know, is the origin the solution? If it is, then the rest of the solutions are going to be on the same side, and if it isn't, then like the other problem, we're going to shade the opposite side. So we have x, which in this case is 0. I want to know, is 0 greater than 2.5? So then I'm like, is 0 bigger than 2.5? No, that's a lie. So it doesn't check out, or you can put false. You don't have to put either one, okay? I just need to see you're checking, if any. So in this case, our test point is here. It didn't check out, so same speech. So we cannot graph it, which means that the actual solutions are on the other side. So I'm going to put, so shade the opposite side. So the side that doesn't contain the test point. So like in English, you can't cover it. So our test point is here. If we shade right here, we're covering it. So we got to shade over here. All right. So I learned my lesson. Let me go ahead and use my highlighter because you cannot see my pencil. Fantastic. So we've got 2 problems where when we checked it, we had a false statement. Hopefully our next problem has a true statement, so that way we can have both sides of the coin. I think that's the saying in English. Cool. All right, problem C. So like problem B, we don't have both x and y variables, and that's okay. So we're either, the boundary line is either gonna be a vertical line or a horizontal line. If you keep your cool, bringing back your number sense, feeling comfortable with numbers, y only, that is code for horizontal line, but you don't have to memorize that. Let's go ahead, do a table of values, and then quickly confirm that we have a horizontal line. So let's go ahead, solve for y. We isolate the y term, we'll add 3 to both sides, and that will leave us with 2y is less than 7. To finish it off, to get rid of the times 2, let's go ahead, divide both sides by 2, and that will give us y is less than 7 halves. So we have a horizontal line that intersects intersects the y-axis at 7/2. Who knows where 7/2 is? Not I. So let me go ahead and write it as a mixed number or a decimal. Students like to favor the decimals over the mixed numbers, so I give the people what they want. So let's go ahead and do an XY table. In this case, the value of y is locked in at 3.5. So we're going to pick random x values. You know what I'm picking, 0, 1, 2, and 3. But I'm not an overachiever, so we'll just pick 0 and 1. When x is 0, the procedure is substitute a 0 for x and solve for y. But there is no x, and y still equals 3.5. So let's go ahead and graph this bad boy. So from the origin, x is 0, y is 3.5. So we're going to stay put and then go 3.5 units up. Cool. So then my next favorite x value, 1. Cool. So again, you can pick any x value. So for this paper, it has to be between -5 and +5. Okay. So when x is 1, procedure substitute a 1 for x and then solve for y. But there is no x and y is still 3.5. So let's go ahead and graph it. From the origin, we're going to go 1 unit to the right and then 3.5 units up. Cool. And then the question is, before we connect the points, because it's not an equation, it's an inequality, are the points on the boundary line part of the solution? So in English, can I graph it? And in this case, unfortunately, we cannot, because the inequality symbol does not contain the equal to part. So we have to do a fake line. Again, don't say that outside of this video. We have to do a dash line to let the reader know that none of the points on the boundary line are part of the solution. So let me go ahead and take my straight edge, because I'm using this clear one so it gets lost easily. Okay, so let's go ahead and do our dash line. Cool. All right, so I did my best. Fantastic. Cool. So now when we do our fake line or our dash line, we're telling the reader that the boundary line is out. So none of the points on the boundary line are part of the solution. But the question is, where are the actual solutions? In this case, are they above the boundary line or are they below the boundary line? I can't eyeball it until we go to the next technique. So let's go ahead and select the test point. So hopefully I can test out 0, 0. 0, 0 is not on the line, so let's do it. Okay, so we're gonna go ahead test out 0, 0. If you're like, no, I'm gonna challenge myself, I'll pick like 4, -4. Yeah, go for it. It's your grade. Fantastic. So let's see if the test point is the solution. So we're gonna substitute the coordinates, 0 for x and 0 for y. So we have y, which is 0. I need to know, is 0 really less than 3.5? And the answer, yes, it is. 0 is less than 3.5. So it checks out, or we get a true statement. So because our test point is a solution, then we can graph it. Okay, but that's only one other solution. Where are the rest of the solutions? The remaining solutions are going to be on the same side. So the moral of the story, this is how it's going to go down. As you do your test point, if it doesn't check out or you get a false statement, you're going to shade the opposite side, the side opposite to where the test point is located. But if you have a true statement or it checks out, then we're going to shade the same side. So shade the same side. So the test point is here. Let's go ahead and cover it. So again, I would love to use my pencil, but we had technical difficulties with the pencil. Now students, can you use a highlighter? Of course you can. Okay, but you have to be very confident in your skills. If you're scanning your work for whatever reason, you need to make sure that we can see the shading. Okay, if not, then you will have to use a highlighter. If you use a pencil, don't be lazy. Shade it nicely all the way. Okay, cool, fantastic. So I said that we were gonna go ahead graph the inequalities by using two techniques. We were gonna use the test point method and the above or below method. Give me a sec and then we'll do the other technique. Okay, so let's go ahead. I'll wrap up this video by introducing my favorite way to graph inequalities, which is by shading above or below. In order for us to use this technique though, we have to make sure that the inequality is in a slope-intercept form. Okay, if it's not in slope-intercept form, then we cannot use this technique. But that's not what should he say? That's not a deal buster or deal breaker. I think deal breaker is the appropriate terms in English, but that's not a deal breaker for me because even when I use the test point method, when I want to draw the graph of the boundary line, I solve for y or put it in slope-intercept form. So the question is, how do we graph an inequality by shading above or below? One, we're going to graph the boundary line like we did before, and then two, we're going to quickly make the call if we're going to shade above the boundary line or below the boundary line. So if we had a horizontal line, let me take out my crooked popsicle stick. If we were to shade above the boundary line, then this will be the above part. If we were to shade below the boundary line, then we shade the below part. How can we tell if we're going to shade above or below the boundary line? Well, that is dictated by the inequality symbol. If once you solve for y, okay, like problem A, this is not solved for y. It's in standard form, so I can't make that above or below call. Let's solve for y, and once we do, then we'll look at the inequality symbol. If the inequality symbol has one of the is greater than, so is greater than or is greater than or equal to, then we're going to shade above the boundary line. But if the inequality symbol has one of the is less than, so is less than or is less than or equal to, then we're going to shade below the boundary line. But again, before you can make that above or below call, you need to make sure that this is solved for y or written in slope-intercept form. If not, then you're going to get the wrong answer. So let's go ahead knock out this fun problem. So it reads, graph the solution set, and then again, if we're doing lines, please use a ruler or straight edge, because more than likely you will get dinged if you fail to do a straight lines. So let's do this. I want to point out that the directions doesn't specify what technique to use, if we should use the test point method or this above or below method. So we're going to use the above and below method. So let's go ahead and do the graph of the boundary line. So we will solve for y. We'll subtract 3x from both sides, and that will leave us with negative 2y is less than negative 3x plus 4. Let's go ahead solve for y. Isolate the y. To get rid of the times 2, let's go ahead divide both sides by negative 2. And then a gentle reminder, at any point, if you when working with inequalities, whenever you multiply or divide by a negative, you gotta reverse the direction of the inequality symbol, or as the young people say, flip it. Okay, so that will leave us with y. You got to flip it, is greater than, love yourself, highlight the coefficient of x, is greater than 3/2 x minus 2. And this is how it's going to go down. Let's go ahead, write down the game plan so we can like show to the world that we got this. So let's identify what we need to do the graph of the boundary line. The slope is 3/2. The y-intercept is at negative 2. The question is, can we draw the graph of the boundary line? The inequality symbol does not contain the equal to part, so we cannot draw the graph of the boundary line. So more love notes. We're going to do a dashed line. Once we do our boundary line, where are we going to shade? Are we going to shade above the boundary line or below the boundary line? So to make that call, we're going to look at the inequality symbol at this point, not the original one, because the inequality has to be written in slope-intercept form. Because we have one of the is greater than, we're going to shade above the boundary line. So this is our game plan, okay? You don't have to write this, but I recommend that you speak to yourself so you can execute it. So it's about to go down. The y-intercept is at negative 2. Let's locate negative 2 on the y-axis. The slope is 3/2, so we're going to go up 3, 2 to the right, up 3, 1, 2, 3, and then 2 to the right, 1, 2. We have said that we should have a dashed line, so let's go ahead follow our game plan. So again, please use a ruler or straight edge. If worst comes to worst, you get a sheet of paper. No, actually no, those will kind of tear. Any hard plastic, like if you got like a gift card or whatever, or your ID, that works. Okay, cool. And then we had said that we're gonna shade above the boundary line, but this is the thing though, where is above the line? Okay, so I'm gonna share with you a finger trick that a student shared with me. I'm not gonna take the trick. So for me, I would love for you to look at this graph and be like, bam, this is the above part. But what if you're a little bit nervous? So go ahead, do this with me. Put your finger anywhere on the screen. okay? And the word above kind of reminds me of going up. So we're gonna move our finger up, not like tracing the line, but like up, like elevator. So we're gonna go ahead, go up. And I want you to notice what is the area that your finger is touching. Well, this top half right here, so that's the above part. So if you don't trust yourself, let's instant replay it. Put your finger elsewhere on the line. Above kind of reminds me of going up, like, you know, when going up in the elevator. And this is the whatever area your finger's touching, that's the above part. So that's the part that we're shading. So go ahead, use your pencil, do what you gotta do. I gave you my speech why I'm using a highlighter. Cool. All right, fantastic. So let's go ahead, wrap up the final problem of this video. It's a pretty long one, but I hope you find it of value. Okay, so problem B, home run. Too bad there's no baseball season right now. Okay, so let's go ahead, graph this bad boy. So you can graph the line by using a table of values or using the intercepts, but for me I like using the slope and y-intercept. So let's go ahead, use that strategy. So we're going to isolate the y term. Let's go ahead, subtract 2x from both sides. That will leave us with 3y is less than negative 2x plus 3. Work your magic, isolate the y, get rid of the times 3. To get rid of the times 3, we're going to go ahead, divide both sides by 3, and that will leave us with y is less than, love yourself, highlight the coefficient of that x term. Y is less than negative 2/3 x plus 1. Cool, we did it. Now let's write down the game plan. The slope is negative 2/3. Let's go ahead, put the negative with the numerator. The constant term is 1, so that's our y-intercept. Can we do the graph of the boundary line? You know what? We're gonna change this problem, okay? Because I wanted to have one that had the equal to part, and the other one didn't. We're not gonna change the top one. So let's go ahead, let's go change it. Okay, so go ahead, update that on your notes. So we change it from is less than to is less than or equal to. Yeah, things happen. Okay, so let's go ahead, update that inequality symbol. Okay, so our brand new problem. Okay, so let's write down the game plan. So first we're gonna write down what we need to draw the graph of the boundary line. So we identify the slope, the y-intercept, and then make the call if we can really graph the line. The inequality symbol has the equal to part, so that means we can graph the line. So let's go ahead, put solid line just to keep it consistent with the book. Okay, once we do our line, the question is on which side of the line are we gonna shade? Are we gonna shade above the boundary line, or are we gonna shade below the boundary line? Because we have one of the is less than, then we're gonna shade below the boundary line. So let's go ahead and do this. So our y-intercept is at positive 1. Our slope is negative 2/3, so we're gonna go down 2, 3 to the right, down 2, 3 to the right, 1, 2, 3. Hopefully I know how to count. If not, it's okay, you can fix it later. We have established that we can draw the graph of the boundary line, so let's go ahead, take our straight edge and connect the points. Please use a straight edge. If you fail to use a straight edge, you will get dinged. Cool. All right, and then according to our game plan, we said that we're gonna shade below the boundary line. So again, hopefully you can see which of the two is the below part. Depending on how depending on the slope or how the line is oriented, the above or below may look a little bit different. But if you're having a moment, again, do the finger trick. Put your finger anywhere on the line, and then below kind of reminds you of going down, like when you're going in the elevator. So we do it in slow motion. I want to point out what is the area that your finger is touching. Well, it's going to be this part right here, so that would be the below part. And then same speech, if you want to do an instant replay, go for it. You put your finger elsewhere, move below, and that will be the below part. Oh gosh, so this is fantastic. This is my favorite unit. Cool. So this problem wraps up the end of this video. In a later video, we're gonna do a spicier problem, combining the techniques that we did for this one. Okay, so let me just finish coloring. I should tell my preschooler to finish this for me. They will get a kick out of this. Oh, I miss coloring. That was so much fun. Okay guys, Thanks.